Hello and welcome to another lecture by Maheen Math Notes. This lecture is going to be about trigonometry. Now, what is trigonometry? Trigonometry is a branch of mathematics concerned with the relationships between angles and ratio of lengths. The field emerged in the Hellenistic world during the 3rd century BC from applications of geometry to astronomical studies. The Greeks focused on the calculation of chords, while mathematicians in India created the earliest known tables of values for trigonometric ratios. Now it's time to move on to the prominent ancient Greek and ancient Indian mathematicians. Hipparchus, on the left, accurately calculated the length of the year within 6.5 minutes. He also compiled the first earliest known star catalogs, as well as coming up with one of the earliest known formulas of modern day trigonometry. And then on the right, we have Aryabhata from India, who first came up with the approximation of pi, and who correctly thought that the reason why planets shine at night is because of the reflection of the sunlight from the sun. And he also correctly believed that the reason why the stars revolve around the Earth at night was due to the Earth's rotation. Now, moving on to the two subfields of trigonometry. There are mainly just two different subfields within trigonometry. The first is plane trigonometry. The second is spherical trigonometry. Plane trigonometry calculates the angles of plane triangles, and spherical geometry is used to calculate the angles of triangles that are drawn on a sphere. Now here we have two very good prime examples of one spherical trigonometry and another plane trigonometry. On the left, we have the unit circle, which is used to calculate the measurements, sides, and radius of certain triangles within a particular area that's shaped like a sphere. On the right, we have a plane trigonometry, which allows you to measure the distance between two different points using triangles. And thanks to the magic of triangles and measuring their respective angles, we are able to calculate not only different objects across large distances, but also the movement of those particular objects. This is the magic behind trigonometry. Now that we've gone over some visual examples of trigonometry, let's go more in depth into the math behind these two trigonometric examples. Plane trigonometry. Plane trigonometry is used for determining the height and distances of the angles in a plane triangle. This type of triangle has three vertices, point of intersection, on the surface, and the sides of the triangle are straight lines, and the general form is always x2 plus y2 equals 1. Spherical trigonometry deals with the triangles that are drawn on a sphere, and this type is often used by astronomers and scientists to determine distances within the universe. Unlike core or plane trigonometry, the sum of all angles in a triangle is greater than 180 degrees. Sine and cosine tables are used, as well as latitude and longitude variables for determining the distance between 2 points. Alright then, now that I explained what trigonometry is, it's time to go over some quick examples. So here we have some plane trigonometry examples. The relationship between the sides of the tangent function is opposite to adjacent side, opposite or hypotenuse to opposite side, or hypotenuse to adjacent side. Now then, let's look at a quick resource in order to answer this question, and also answer another question that involves more with numbers. Sine, cosine, and tangent. Sine, cosine, and tangent, often shortened to sin, cos, or tan, are each a ratio of sides of right angle triangle. As you can see, the relationship is sine O is opposite divided by a hypotenuse. And what that means is the length of the hypotenuse divided by, the length of the opposite divided by the hypotenuse. And cosine is the adjacent divided by hypotenuse. And tangent is opposite divided by adjacent. And if we were to look at this particular example, using this triangle, lengths are only one decimal place. Sin equals 35 because opposite divided by hypotenuse is 2.8 divided by 4.9, which equals to 0.57. As you can see, a 35 is the angle. It has nothing to do with the particular number that it has. Cosine is adjacent divided by hypotenuse, which is 4.0 divided by 4.9 equals 0.82. And tangent, 35 degrees, again, is opposite divided by adjacent, which is 2.8 divided by 4.0 equals 0.70. Now then, going back to the original question, the relationship between the sides of the tangent function is, if we recall back to that resource we just looked over, it is opposite to adjacent side. Yes, we got it right. Trigonometry helps study the relationship between the sides and angles of, is it acute triangle, obtuse triangle, or right triangle? Well, I know what a right triangle is, but what exactly is an obtuse or an acute triangle? Let's look it up.